and again. Right. Okay, this is the one about the cell phone. Now, it's given this is the cost equation. Don't worry too much about the C of x. This is just saying how much it costs. So like it's saying, if you was to speak for 5 minutes, you'd put 5 where the x is. If you speak to 10 minutes, you'd put 10 where the x is. So that's all it means. It means, what value of x shall I put into this equation? Okay. Anyway, but this means what's the cost. Now, x is the number of minutes, and that's all we know really. So remember, the thing next to the x is the slope. All right. So 0.12 is the slope. And the intercept, remember, is the number at the end, the y-intercept. So 1960, I'll write it down there, 1960 is the intercept. So that's what we know so far. Again, it's written as y equals m, I'm going to put this, sorry folks, plus b, got a cat on me. Right, remember, y equals mx plus b, or c equals mx plus b for this one, okay? So, hang on. So the number next to the x, there, Thomas. The number next to the x is the slope, and the number at the end is the y-intercept, the intercept. So, now what does it mean in relation to the real world? Well, what it means is that, okay, for the intercept, the $19.60, okay, this here, that is a fixed amount. It's not changing, it is $19.60. That's what the phone company is charging you a month all the time, okay, whether you use the phone or not. That's like, okay, that's what you're paying to use the phone, all right? Now, the 12, the slope, that is 12 cents per minute. Remember, x is the number of minutes. So 12 cents for 1 minute, 24 cents for 2 minutes, 36 cents for 3 minutes. Okay? So that's all it is really. I mean, that's what it means in the real world situation. It costs you 12 cents per minute to make a call, and you're always being charged $19.60 for kind of like using the phone. Okay, that's your phone, but we're going to charge you $19.60 for using it. Okay, so that's that one. Let's just find another one. Okay, so remember this one with the, okay, this is number of lamps being assembled. Again, some of you are pretty good on this, some of you really just saying he worked, he stopped, he worked again. I'm going to do this, I think. Okay, so from that 2 hours, that looks like a 2 hour thing. Okay, oh my God, Thomas. So I can see, okay, so in the first 2 hours, he makes 40 lamps. So that's some information you know, okay? You could say for extra credit, he makes 20 lamps per hour. That's his rate, all right? He's made 40 lamps in 2 hours. In other words, he's working, it's like mile, you don't say you go 100 miles in 2 hours, you say you're doing 50 miles per hour. That's your speed. So he's made 40 lamps in 2 hours or 20 lamps per hour. He then has a half-hour break. Thomas, did you have your lunch break? Half-hour break there, okay? Then he keeps on working, and then for the next, now again, look at it, you've got to be kind of, it can't be super accurate. It looks like until 4 hours later, it's not 4 o'clock, he started at 8, all right? This is just a number of hours after 8 o'clock. So here, for an hour and a half, from, look at this, from 2.5 to 4, okay, that's an hour and a half. He's gone up to, looks like 70. That's 70. Okay, so this is an hour and a half, he made another 30 lamps. All right, so that's the kind of information we're looking for. And then, of course, it looks like it goes on lunch. But now remember, that 4 hours, if we started at 8, that's midday, that's 12. So that's probably his lunch break. Okay, Thomas? Probably his lunch break at 12 o'clock, 4 hours after his 8 o'clock start. And I think that's pretty much it. You can't just say he worked for 2 hours, then had a break, then he worked for an hour and a half and had a break. What's going on? How many lamps is he making? How did he spend the day? Okay? I think that's pretty much okay for that one. I'm not going to do any more than that. I will do one more. Okay, this is another slope one. So last one for this little video. Now look, glass. On the test, it might change. I mean, I put plastics on the test. All right, some people are still thinking it was glass. So where's glass? Here we go, glass. Right, from 2000 to 2008. Okay, so these are the figures here, right? Okay, so now then, if you think about graphs, normally time is on the bottom, okay, which is the x-axis. Okay, so in other words, what we're going to do here again is use the slope formula. All right. Now remember the slope formula. M is the difference in y's. Now most of you kind of realised how much was increasing and decreasing on the test, but then he didn't put it over the number of years. And it was what per year was it change? What's the slope? You know, what was the change per year, not just for 8 years? So again, x2 minus x1. Sorry about this cat here. Yeah, Thomas, he does this. Okay, so we have to realise that these are the x values. Time is the x. All right. So I'm going to go. x2 is 2008. Right. Minus x1, which is 2000. Right. There we go. So that is on the bottom, not on the top. Okay. So again, over those 8, I can see that's 8 years. That's fairly easy. So I'll write it down here. So that's over 8. All right. That's the difference. That's like the run. Okay. Difference in the x's. Now, what's the difference in y's? Now, if that was x2, the 2008, then this is the y2, the 0.28. So write it first. 0.28. Get off the microphone. Minus 0.36. Now, hopefully you see this is going to be a negative answer. Okay, for this one. For this particular instance, that's going to be a negative answer. So, what's 0.28 take away 0.36? Put it in your calculator. Negative 0.08. All right? Okay, negative 0.08. Sorry about the cat, guys. Now, if I put that in my calculator, that's going to give me negative 0.01 as the slope, or what we actually call it for this one, the average rate of change. That's just slope, folks, all right? So it really is you doing this equation again, but we're not literally giving you the numbers to put in it. You've got to figure it out yourself, all right? So the difference in the years is the difference in the x's, all right? The other numbers are the difference in the y's. So y2 minus y1 over x2 minus x1. Okay, so you've got to find it. I think in one of the other tests it used plastics. I think it used those numbers instead. All right, not the glass. It was a plastic question. Other ones might use different years. But remember, the years is the x-axis. Those are the things you put on the bottom. Okay, and that's it. I'll get rid of the cat.